For part 2, we're going to take a look at natural log. Now, the natural logarithm is the inverse of the exponential function with base e. And like base e, 10, we don't ever really write the base. So if I see something like the natural log of e to the 5th, and if I want to solve this, I can set that equal to a. Now, natural log has a base e, so I may want to write the e down there, and that's okay. And this becomes e to the a equals e to the 5th. So we get a equals 5. Now, of course, there is a shortcut for this one. I want to take a look at that. There's a shortcut. If I have the natural log of e to the 5, the natural log of an e, because they have the same base, these cancel each other out. And what am I left with? 5. So you can solve it either way. Let's try natural log of 1. Now, unfortunately, this does not have e on the base here, so I'm going to set that equal to a. We go e here, so we go e to the a equals 1. And you may recall here, 1 is the universal base, that's e to the 0. Therefore, a equals 0. So this all equals 0 right there. For this one right here, there's a little bit of an e there, set that equal to a. Same thing. We get e to the a equals 1 over e squared. Bring it up. E to the a equals e to the negative 2. Whoops, awful. So a equals negative 2. But again, I could also write this one like so. The natural log of e to the negative 2. And because they're the same, the natural log and e have the same base, because they're inverses, they cancel. And we're left with negative 2 right there. And that's going to help us for this one. Let's go ahead and use the shortcut here. Okay? To use the shortcut, I'm going to get the 3. Because natural log and e are inverses of each other, they cancel each other out. And that's going to leave me with just the 4. Plus, now be very careful here, there is a 1 up there. Natural log and e cancel each other out, we get plus 1. And what's 3 times 4 plus 1? 13. Okay. So we're going to take a few minutes, we're going to try a couple more, okay? Also use this property, our inverse property, to solve basic logarithm equations. And if you notice, it's going to be the same thing, except for now we're going to set it equal to a number, like I might set it equal to 3 here. So if I'm solving it using my inverse property, remember my inverse, log base b of x equals y, if and only if b to the y equals x. So I'm going to use that to solve. 2 to the third equal to x. So what is x equal to? 8. Let's try this one. 9 to the x equals 27. Now I can write these as the same base. This is 3 to the 2x, and this is 3 cubed. So what is x going to equal? 3 halves. So easy to use to solve these. Now, another one we can use for log, another property we're going to talk about today is the change of base. Now, this is not normally a property that you use in Algebra 2. And oftentimes, we use this because oftentimes we want to change the base of a logarithm. We want to do this to solve an equation or to evaluate a logarithm with a calculator. Or just to cause unneeded pain and suffering. I'm pretty funny. Whatever the reason, the change of base property is a very easy property to use. Now, for calculator, remember the calculators will only do base e and 10, and that's why we need this property sometimes. So let's say I want to find out what the log of base a, b is. The change of base says you're going to take the log of b and divide that by the log of the base, which was a. And this is our change of base property. And you can use any base you want down here, base 3, base 2, whatever. But we normally only use the common log or base 10 or base e. Rewrite the following logs in terms of the common base. Remember, this is our base is 10 and the natural base. That's where the base is e. And then we're going to evaluate them on the calculator. So if I want this one, I would write, if I want to rewrite this, see, I can't do log base 3 on the calculator. So what I can do instead is I'm going to rewrite it. The calculator will do base 10. So I can write this as log of 5 over log 3. And if I type that in my calculator, log 5 divided by log, don't forget with your log button, log 3. I hit enter, I get 1.465. And there's our log. Now, I could also do this in base E, but in base E, we get the natural log of 5 over the natural log of 3. Now, the question is, are we going to get the same answer? Well, let's find out. I should get the same answer because, well, we can't have two numbers equal to different things. Natural log of 5, remember natural log is just right down here, natural by the 4, natural log of 3. Hit enter, and indeed, we get the exact same answer, and we should, 1.465. So let's take a look at number 2 here together. Do the common log, which is base 10, so that's going to become log 3 over log 1/2. And I just typed in my calculator, log 3 divided by the log of 1/2, I'm going to use 0.5. Now this is going to become negative, because remember, when we graph logs, right, anything less than 1, it was negative. So that should become negative. There you go. Negative 1.585. And do the same thing with the natural log. Natural log of 3 over natural log of 1/2. And I see if I get the same answer. Natural log of 3 divided by the natural log of 0.5. And yeah, we get the exact same thing. Look how exciting this is. Very easy. So what I would like you guys to do is finish up, do number 3 and number 4. Make sure you have them done for tomorrow, okay? And I'll see you guys tomorrow. Have fun.